All right, this is number 35B in our book. It says find the radius and height of a cylindrical soda can with a volume of 354 cubic centimeters that minimizes the surface area if we use double the materials on the top and bottom. So part A does not have the double the materials part. Okay, well, the first thing that I know is that I know the volume is 354, and that's pi r squared h. Okay, that's not what I'm going to minimize. This is what we're calling our constraint. So this is what we're going to solve and substitute into the other problem. All right, let's talk about surface area. So the surface area of just a regular cylinder, okay, is I would want to take the area of the top plus the area of the bottom plus the area of the sides. Okay. For a can, our top is pi r squared and our bottom is pi r squared. What about our side? Well, if you could imagine cutting off the top and the bottom, okay, and then slicing down the side, what we're going to get is a rectangle. And that rectangle will have a height of h, and the length of it will be the length of the circle. And the length of a circle on the outer edge is called the circumference. So this is going to be 2 pi r h. So this is the circumference of the circle. This is the height of the can. So this is going to give me the area of the rectangle. Okay, so I definitely want to solve this for h in terms of r and plug it in here. So that's going to definitely happen. So this is what I want to optimize. However, we have the extra. If I go up there, we double the materials. So basically, instead of having just one here, we're going to have two. And instead of having one here, we're going to have two. So my surface area equation is going to be 4 pi r squared plus 2 pi r. And now I got to go up here and solve this for h. So if I solve this for h, I think I'm going to get 354 divided by pi r squared. So that's what I want to put in over here is 354 over pi r squared. Okay, now what happens to a lot of people is they try to take a derivative now. Let's clean it up for just a second. I can slash out a pi, I can slash out an r, and I can make this a little bit cuter. So let's go ahead and call this 4 pi r squared plus 708 over r. So that's a little bit nicer. Okay, now we're going to take the derivative and optimize it. So let's go ahead and take the derivative. My variable is r. Pi is just a variable or a constant. Okay, so here I'm going to do the power rule on the r. This 2 is going to come down, so I'm going to get 8 pi r. Okay, this is the same thing as 708 r to the negative 1. So this would be negative 708 r to the negative 2. But I'm going to write it that way as r squared. Okay. I'm going to set it equal to 0. And I'm going to find a common denominator. Okay. And when I set the bottom equal to 0, I just get 0, which we don't need in this problem. That would be a can that doesn't exist. And up here, I'm going to get 8 pi r cubed equals 708. So r would equal the cube root of 177 over 2 pi. That's lovely, isn't it? Okay. Which, for those who want to know about what that is, that's about 3.04 centimeters. All right, awesome. We found our r. Yay! Now, is that the one that creates a minimum? We sure hope so. So the only way I can check to see if this creates a minimum or not is to use the second derivative test. I want to make sure that this is the value that minimizes it. So hold on while I erase. All right, so is it the one that minimizes it? I'm going to take the second derivative, and And if I can do the second derivative, I get 8 pi. Negative 2 times a negative 708 is a positive 1416 r to the negative 3. If I plug this in, if I plug this 3 in here, I get a positive number plus a positive number. So that means it's positive, it's concave up. And if you're concave up, that means that you've got a min. So this is just my way to make sure that I got the type of extrema I wanted. Because I'm looking for a minimum, and if this gives a max, then I screwed up somewhere. Okay, so what are the dimensions of a can that minimizes the surface area if we use double materials? Well, R is 3.04. What the heck is H? So if R is 3.04, then if I plug that into this expression, then what I'm going to get is that H is 12.2, which is a lot closer to the actual size of a soda can that is currently selling in the supermarket. All right. There it is in all of its glory. Okay, good luck with this problem. I hope it goes well.